Okay, thanks very much for Thanks very much for having me participating in this important discussion. And we have heard this morning about different ways of recording brain activity, reading brain activity, and stimulating or modulating the brain activity. And I'm a neuroscientist, and in my lab, we actually record from neurons, explore the cerebral cortex, and use these technologies. However, the one I'm going to be telling you mostly about now is about a technology that doesn't directly stimulate the brain or record from the brain, but it has a very large impact on brain function and on behavior. And this technology is virtual reality. I have been using it for over 20 years because as a neuroscientist, I realized of its potential to investigate how the brain works. So, as you probably know, when we function in the real world, we receive information through our senses. They are encoded. This information travels from our sensory nerves to the brain. We perceive, and then we can interact with the environment through our motor system. We investigate, we explore, we touch, we navigate. So what happens when the external world is completely replaced by a virtual environment, and when our cells are also different? What is going to be the impact on the brain? What are going to be the applications on this context? So, immersive virtual reality, what it does is that it digitally recreates completely the external world, and also ourselves. It's a digital representation. It provides, therefore, all the sensory information, auditory, visual, tactile, is going to come now from a computer-generated information, and we are going to interact with it as well. So you have probably heard about the discussions about the metaverse, the new system, Vision Pro from Apple that came out last week, where you can literally regulate to what extent with the knob you are in the real world, and you turn this knob, and gradually you can go to augmented reality and then to a totally immersive world. So what happens for us when we do this? So on the one hand, we have the external world that is replaced. It's replaced by this digitally generated environment where we obtain all the sensory information, and we have a sense of presence, which means we have the sense of reality, and we respond to it as if it were real, even if we know that it is not real. So there is this replacement that can be of a realistic world, or it can be a completely different world. It can be fantastic. It may even not follow the physics from the real world. This is very interesting to investigate how our brain adapts to these radically new conditions. So therefore, it's going to be a very interesting tool. But we can also replace ourselves. We can look down. We can see our body. It can be a completely different body. And we are going to have an illusion of embodiment, because this body is co-located with our real one. It's going to move with us. And we are going to have this illusion that this body is our own body. We are going to have this embodiment in spite of the aspect of the body. It can be of a different age, different size, different height, different race, different gender, and still we are going to have this illusion of embodiment. And this is going to have an impact on us, and this has been proved by our group in many studies, but also by many other groups. So there is going to be, we heard this morning to Dr. Damasio about interoception, the importance of interoception. Even we can replace interoception, we can provide virtual false feedback of a heart rate or a respiration such that it gives us an illusion of being more anxious, for example, or less anxious. And so therefore, if we replace the whole body, we can also have a motor control of our virtual body. This can be realistic, it can move with us, but we can regulate the gain of this movement or even the movement itself. So therefore, we have a completely virtual body, and in a way, our body is an interface to our brain. So if we modify this virtual body, we can act in the brain, and this explains some of the applications, like this has been used, as you can imagine, very much for neurorehabilitation. So there is this impact, therefore, on brain, on behavior that is proved, is known, and therefore, this is the origin of the applications. There is another aspect, which is the social representation. Often people think of virtual reality like a place where you're going to wear a helmet, you're going to be isolated. But this is not the case, because actually they can be populated. There are avatars there. They can represent real people that are anywhere in the world. Or they can actually be avatars. They can be controlled by an artificial intelligence. And what you can see here is very cartoonish, but nowadays we can generate in a few minutes an avatar with a photograph, which is very precisely some specific person. So a very important aspect of this is not only that you can have social interactions, but of course, here we are interested about the brain, how we are going to respond to the others, and we can use it in different ways. And I'm going to illustrate it with some specific applications. So if we go to applications, I have been particularly interested in medical applications. For example, we have investigated how modifying the brain can reduce pain, and we have demonstrated this in healthy people, but also in people with chronic pain. And we have also worked, as well as many other groups, on neurorehabilitation, even orthopedic rehabilitation, how we can use our virtual body in order to have this rehabilitation. This can be integrated or not with robotics, for example. And of course, it can be used for training and so on. But I'm going to tell you a bit of two examples of a different one in relation to the social representation. So because we can have embodiment, we can go into someone else's shoes. We can take the perspective of other people. Let's say we can go in the body of other people and have a completely different perspective of a situation. And this we have been used as a tool. Specifically what you can see in this slide is aggressors. It has been used with aggressors that take the perspective of the victim. And this has turned out to be a very useful tool integrated in rehabilitation programs, where we went from the lab after many years of studies, is now being used in different prisons, and actually last week it got a Europees Prize as a good application to help with rehabilitation of aggressive behavior. And also I would like to mention, I'm one of the co-founders of a company, Keen, and what is being used now, this taking the perspective of another person now, is in order to do training in diversity, equality, and inclusion. And here you can see this is being used in corporations for doing this training. Well, and then to finish, I would like to mention that we have heard before about brain-computer interfaces. We can, of course, connect virtual reality, control it by thinking. We can control it through brain-computer interfaces. They can be invasive, non-invasive. This is from a study we did in 2009. It's a non-invasive EEG, controlling, in this case, a virtual arm, but you can control a whole body. And I would like just to mention one study. Of course, when we control a body, there can be some limitations of how precise this control is. This can be used, for example, for moving a virtual body before you apply to robots to control a robot. Basically, the signals are the same. But we did a study. I was interested to understand to what extent do we feel agent, we feel owners, responsible of our actions? Because when we control an apparatus or a robot by thinking, how do we feel about it? Do we feel that we are agent? And we did this in a study with a virtual body, and we found that it depends actually on the areas that you use to trigger the signals for motor control. So if we, well, in this case, you have seen there is an action, there is a movement controlled by thinking, and there is an unexpected action of throwing away this glass there with pencils. And we measured to what extent people felt agent, felt responsible, and we found that actually it depends on the area that you are activating, on the activity pattern. So I think this opens also a discussion of how, yes, of not only whether we can do it, but also how do we feel responsible about those actions. I think it's also an important aspect, and of course the fact that these technologies are important, and also they open an important debate. Thanks.